Now I will take the questions in the second pass. Okay. So one of the biggest issue with images is when we are using ANN, we are flattening it. By flattening it, we are killing the spatial integrity. How do you get all the information from the image without killing the spatial integrity? By applying a filter. What is a filter? A filter is a matrix of values. When you apply a filter, a new image will be formed. Filter, like you move the filter in 2D, like you move it this way and this way. Conv 2D it is known as. The layer name is conv 2D. You move it in the rows and columns. You keep on moving that side and this way. So a new image will be formed when you apply a filter. This is the original image. This is the convoluted image. In this convoluted image, particular feature can be highlighted if you change the values of the filter. By changing the values of the filter, particular feature will be highlighted. Particular feature will be suppressed. There are particular these features, these filters are also known as kernel matrices. If you change the values of kernel matrices, particular features will be highlighted. Here is an example. If you apply this kernel matrix, then straight lines are highlighted. If you apply this kernel matrix, horizontal lines are highlighted. But how do I know? How do I know which kernel matrix to apply? You don't need to know. You don't need to know. This is the important note. You don't need to know. You just need to provide the kernel matrices. That's it. You don't need to provide the values of it manually. You randomly initialize them. Whatever features are there, see, these are the features that I'm telling you that will exist. There are some features that cannot be perceived by human eye. Do you agree with that point? Not every feature in this world we can see that. There are some hidden features. There are some features that are there in the images that we can't even see with our own eyes. There are there. You have to find them. How do you find them? By giving sufficient number of kernel matrices. We are going to see how do you configure number of kernel matrices. How do you say different kernel matrices? We will give sufficient number of kernel matrices. Then one of the kernel matrix will end up like detection of curves. One of them will end up like detection of circles. One of them will end up like detection of sharp edges. One of them will end up like horizontal lines. One of them will detect vertical lines. All these features put together will be helpful in doing the image recognition. So features are detected based on the data. All that we need to do is give the kernel matrices with different weights, randomly initialized weights. So what do we do in convolution neural network is we will give sufficient kernel matrices. We'll configure sufficient kernel matrices to detect low level features, sufficient kernel matrices to detect the mid level features, sufficient kernel matrices to detect the high level features. Then we are through. All the features are there. Then it is a trainable classifier. It will be very easy. After that, image processing will be very easy. Image recognition will be damn easy. So it need not be 3 by 3 always. It need not be zeros and ones always. There can be different numbers as well. Okay, go on. There was some question. So whatever is in your mind right now, whatever you could not understand, you can either write the question in the chat window or directly ask me. I'll try to read out the question and try to answer it. We're going to see some more details. We will see with our own eyes how filters are applied and all that. But before that, intuitively, just an introduction to filter is what we have discussed. So by changing the values of the kernel matrix, the resultant image will change. These are some of the general filters that we have already seen in the outside world until now, but we are not interested in this type of fancy images. Here we are doing image processing, image recognition, object recognition, or image classification. We are not interested in creating a fancy image. Maybe in the filter of your Android phone or in the filter of your iPhone or your Instagram, they may have a static filter that will make the image look like this. They may have some static filter for Amaro, Rise, or Hudson, X Pro. They may have some static filters. We are not interested in that. We are interested in the filters that will detect the features. We are not interested in the filters that will just transform the images to a new value. Are you with me? So the first layer in the convolutional neural network is convolution layer. What happens in this layer? We take the image as input and then we apply filter on it. When you apply a filter, what will happen? Tell me, when you apply a filter, a particular feature will be highlighted. Rest all features will be suppressed. If you take an example, if you take this image of a cat, if you apply a particular filter, then maybe, see, not everything can be perceived by human eye very easily. I'm just guessing. Maybe if you apply this filter, this particular out shape of the cat is highlighted. If you apply a different filter, maybe this particular shape of the cat is highlighted. Maybe when you see in the car, you may not find this shape and this shape. Maybe this kind of thing may not be found in the car. That is where the classification will be easy later on in the algorithm. That is how convolution neural network works. We haven't seen the complete one of it. The major difference from ANN to CNN is applying the filter. The first layer itself, you have the input layer. Earlier we used to take the image and flatten it, but now we have to keep the image as it is in the input and then apply a filter on top of it. Even drawing the convolution neural network architecture will be difficult for us because it has to be somewhat 3D form we have to put it. Do we apply only one filter or we apply multiple filters? Tell me. If you have understood the whole story until now, do we apply only one filter or do we apply multiple filters? Which one is required? What is required in real world? Multiple filters are required. That is right. Because why multiple filters are required? Multiple features are there. In images, we usually have multiple features. Let us see an example. We will take this cat image. Usually we don't really get to see what happens in the convolution layer, but just to give you a flavor, what really happens is, what we are trying to do here is, we will take an image, we will apply this 5 by 5 filter with some random values and check what is the result. All of you open the code file, open the code file. Let us see an example. Open the convolution neural network code, import the cat image. Usually you will not get a chance to see the convolution layer or convoluted images. In reality, you cannot see them. Impossible to draw. Here we are just displaying so that we understand what is happening in the background. Okay. Model sequential, model.add, model.add, conv 2D. Do you understand what does conv 2D mean? Conv means convolution layer. 2D, why it is known as 2D? Why it is known as 2D? When you are applying the filter, you move row wise and column wise. That is why it is known as conv 2D. Kernel size 5 cross 5. Can somebody tell me what is kernel size 5 cross 5? What is kernel size 5 cross 5 mean here? Conv 2D means you are applying the filter this way and this way on the whole image. A matrix of size 5 cross 5. And what are the values filled in that matrix? Can you see the full code and tell me what are the values filled in that matrix? 5 cross 5, are they all zeros or there's something else in there? What are the values? There are some random values. Where did we give that? Fill it with some random values. Where did we give it? Kernel initializer random uniform is mentioned. Random values are given. Okay. Look at this. When you apply this particular kernel matrix of 5 cross 5 on this image, it will highlight a particular feature. Now your result may be different from my result. The reason is random values. Your random values are different. Particular feature will be highlighted. My random values are different. Particular feature will be highlighted. As a matter of fact, if we re-execute it, again, my result is changing. Why? Random values. Re-execute it. In reality, it won't happen like this because in reality, we will be learning based on the data. So we will have the kernel matrix detecting particular features. Here, there is nothing to learn. Single image is there. We are applying just for the fun sake. We are applying a filter. on top of it. Each filter is highlighting few things. Can you see what I'm seeing here? It is highlighting, let's say, nose and eyes. All of you see this here. Nose and eyes, near the ears, a particular portion is highlighted. Okay, let me apply another random filter on top of it. That time that filter may not highlight those. Somehow I could see that these ears and that portion, that non-white portion, seems to be highlighted by this kernel matrix. Check that out, all of you. What I want you to do is re-execute it and check what kind of filters are highlighted. Not every time you can make sense out of it, because some things are beyond our human eye. There are particular features that you cannot see with your own eyes, or isn't it? Maybe only the system will detect a particular feature. That is what happens at the convolution layer. In the convolution layer, what happens at the convolution layer? We take the original image, we get some convoluted image. Now the convolution layer has depth to it. Convolution layer has depth. What do you mean by depth? You have the original image. If you apply one filter, then you will get one convoluted image. Look at this, all of you. I have one single image. All of you, please focus here. I have one single image. If I apply one kernel matrix, then I will get one resultant image. Yes or no? But do we apply one matrix, or do we apply multiple kernel matrices? Once again, I'm asking you that question. Do we apply one matrix, or we apply multiple kernel matrices? When you apply multiple kernel matrices, do you get multiple convoluted images or not? From one single image, do you get multiple convoluted images, or will you get a single convoluted image? When you apply multiple kernel matrices, obviously you will get multiple images. So this is one kernel matrix. We don't give the numbers, random values we will give. This is one image. On the same image, apply another kernel matrix, you will get second image. Yes, maybe here this is the one. This is a filter that will highlight the horizontal lines. This is a filter that will highlight the vertical lines. This is a filter that will highlight the zeros. This is a filter that will highlight this cross, this one, like that. Will give multiple kernel matrices. That is why convolution layer has depth in it. Are you with me, all of you? Convolution layer, it has height, width, and depth. And what is the depth of convolution layer equal to? You have to carefully understand this. The depth of convolution layer is equal to the number of kernel matrices that you are applying in that layer. If you, yes, number of kernels, that is right. In the previous exercise here, in the previous exercise, what is the depth of the convolution layer? In the previous exercise, what is the depth of the convolution layer? Hey, the depth of the convolution layer in our exercise is 1. But in reality, usually the depth of convolution layer, will it be 1 or a little more than that? It will be much more than 1. Okay. Convolution layer has depth in it. All of you, have you understood the depth of the convolution layer? Each value from the filter matrix is a weight. Those are the weight values, and it will give convoluted image, and convolution layer has depth in it. Are you with me? Now, shall we calculate the number of weights now? Shall we calculate the number of weights? Let us start with a single filter. This is a single filter. Each one of them is a weight. Yes or no? W1, W2, W3. We don't know what are the right values. All of you need to acknowledge this point. How do I know the weight values? I don't know the weight values. That need to be found based on the images, based on the training data. Number of weights in one filter here. How many are there? Number of weights in one filter. 1, 2, 3, 4, 5, 6, 7, 8, 9. And one bias term, the one that we don't show it usually. One more bias need to be added. Yes or no? One bias term is always there with us. 9 weights. Do you remember the bias term? W naught value or the beta naught value. 10 weights for one filter, right? If you apply 5 filters, now tell me how many weights are there. If your first con 1, let's say this is convolution 1, layer 1, you applied 5 filters, all of you applied 5 filters, and each of them is size 3 cross 3. How many are there? 9 plus 1, 10 into 5. That one bias term we cannot miss it, no? That technically speaking, that additional bias term will be added, so it will be 50. So 45 is correct answer. 3 cross 3, 9 weights are there. 3 cross 3, 9 weights. But one more bias, so overall 50 weights are there. Do you see the number of weights that are reduced drastically here? Have we answered both the problems that we had earlier previously? Have we answered both the problems now? What was problem number one? Problem number one with ANNs, number of free parameters. It was running into millions, billions. Now it is into tens. Even if you have 30 kernel matrices, still it will be in thousands only. Do you agree with that point? Yes or no? If you have, let's say, 30 kernel matrices, or even if you have 100 kernel matrices, can you tell me if 100 filters are applied? Can you tell me the weights? Quickly give me the number. If 100 filters are applied, tell me the weights that you are going to calculate. As many as 100 filters you applied. Each filter has 10 weights. Overall, 1000 weights. Where is 1000? Where is a million and a billion? Don't you think we have reduced the weights, number of free parameters drastically? Yes, CNN answered that question. Have we kept the local correlation? Are you looking at the local correlation? Are you considering the pixel around its surroundings, etc., etc.? Somehow you merged, managed all of them into one pixel? Yes. So spatial integrity kept intact. Local correlation kept intact. Number of parameters, free parameters kept low. CNN started working superbly on images. Okay. So the story until now is ANN is a powerful algorithm. We do have a lot of respect for it. However, ANN has some problem. What is it? Number of free parameters is an issue. The spatial integrity is lost. Then we introduce CNN. The trick here in CNN, the name is also coming from that filter only, convolution layer. What is a convolution layer? We applied a filter on top of the image. When you apply a filter on top of the image, it will give you the convolution image or convoluted image. If you apply multiple filters, your image is the input layer, input is the image, you apply multiple filters on it, then you will get the multiple convoluted images. That is known as a convolution layer. That is the first thing which solved a lot of problem. Now to make it much more effective, the other things are added. These are some of the practical considerations. The first practical consideration is we have to do downsampling. We have to add something called pooling layer. We have to add pooling layer. What do you mean by pooling layer? In the convoluted images, there is lot of duplication. There is a lot of repetition that has happened. Do you agree with that point? Look at this, all of you. The information present in 3, a lot of information matches with 4. The information present in 4, a lot of information matches with 3. Do you agree with that point? All of you? First we apply the filter here, then a portion of it here, then a portion of it here. There's a lot of repetition of information. Do you agree with that point? Is it fair to say there is a lot of repetition of information? Or there is exclusive information, there is nothing that is common? There is a lot of repetition of information. Think about it once again. So how this number 3 is obtained when you apply this on top of this? If you're applying a 3 by 3, yes, and then if you're applying this one, so there is a lot of repetition of information. Then we can comfortably do something called downsampling. In downsampling, what do we do is we just take the subset. So let's say if the image is 1000 by 1000, in downsampling, after pooling layer, downsampling is done by adding pooling layer. It will be simply 500 by 500. We will reduce the image. In terms of rows, we will half it. In terms of columns, we will half it. Almost one fourth of the image. Or in terms of rows and columns, if you see, almost the size will be halved. And it is not dangerous. Not at all a problem. Practically, you will never face an issue. That is known as pooling layer. We do max pooling, average pooling. What do you mean by max pooling? What do you mean by average pooling? Let us see. Let us suppose this is the image. It has 1, 2, 3, 4, 5, 6, 7 pixels. 1, 2, 3, 4, 5, 6, 7 pixels. If 7 cross 7 is the image, usually this is a standard static one. We apply 2 cross 2 pooling matrix. 2 cross 2 pooling, 2 by 2 pooling. Okay, 2 by 2 matrix, and then we do the pooling. And exactly half rows, 3 rows, 3 columns. 3.5, 3.5 not possible. So you have to say, even if it is 6 cross 6 or 7 cross 7, 3 by 3 will be there. If the image is 8 by 8, what will be the result? If it is 8 by 8, the result will be kind of 4 cross 4. Let us see how that is applied. You take a matrix of size 2 cross 2 and apply the matrix in the row wise, column wise. This time the stride has to be 2. Look at this. You apply this 2 cross 2 matrix. Let us say if you are doing max pooling, take the maximum value out of these 4 values. Maximum value is 6. Fill it here. Come here. You have to keep the stride as 2. Look at this, all of you. Until now, we moved with stride 1. Do you understand stride 1? Stride 1 means after this, we moved here only. Like if you are moving after applying this, after applying on here, if you are moving here, that is known as stride 1. You moved by 1 stride. If after applying here, if you skip 2 and move here, earlier we skipped 1. Now if you skip 2, move here. That is known as stride 2. Usually pooling is done using 2 by 2 matrix with stride 2. That is a kind of static or constant usual notion. Look at this, all of you. So when you are doing max pooling, you apply 2 cross 2 maximum value. Then stride to 2 cross 2 maximum value. Come here 2 cross 2 maximum value. How much is the maximum value? 6. Okay. Let me fill the resultant image. 3 cross 3 max value. 3 cross 3, 2 cross 2 max value. Here what is the number? 6. Can you tell me the last 3 values here? Tell me what is the value here that I have to fill. What is the value here? What's the value? Pooling, max pooling we are applying. If you are applying max pooling, the 7 by 7 image will be your 3 by 3 image. The value over here is 6. What about this one? 6, 4, 5. Is it correct? 6, 4, 5. So this image will be given as this. You might think that, hey, I might lose a lot of information. You know what? You will not lose the information because there is a lot of repetition here. Don't worry about it. This is known as max pooling. Kind of practical consideration. Can I avoid pooling altogether? You can. No need to worry about it. But pooling helps in reducing the size. It can, give you a result very quickly. One more pooling is there, average pooling. Based on your experience with max pooling, can you make a guess what could be average pooling? What exactly may mean average pooling? This is also pooling only. This will also reduce the size. What it may mean to say average pooling? Average of the 2 by 2 matrix. Earlier max value of the 2 by 2 matrix. Now you take the average of the 2 by 2 matrix, fill it here. But what I have seen is people don't use average pooling, though it exists as a concept. Max pooling 2 by 2 stride 2 is the default one that everyone uses. What happens in the pooling layer? All of you, what happens in the pooling layer? Image size will be reduced. Almost rows will be halved, columns will be halved. A practical consideration, which is very useful when you are building the models. Without this, can I survive? Yes, you can. But I don't suggest that you avoid this pooling. Are you with me? How many parameters are there in the pooling layer? No parameters in pooling layer. You're not doing any kind of detection or anything. You're simply reducing the size of the data. So the next layer is known as pooling layer. What happens in the pooling layer? Simply we apply the pooling layer and the image size will be reduced. What I want you to focus on here is, if you look at the image size, rows are somewhere around 3700, like 3560. Columns are, this is the height, this is the width, 5360. If I apply 2 by 2 pooling, can you make a guess what will be the resultant image? If I apply 2 by 2 pooling on this, what will be the resultant image? Instead of 3560, some 1700 will be here. Instead of 5360, some 2600 and odd will be there. Look at that result. Can you see that? 2600 odd, 1700 odd here. Pooling layer doesn't really see the result here looks exactly the same to a human eye. What is the difference? Check this out. This cat over here, this cat over here looks very similar to you. Can you tell me what is the difference between these two cats? Anybody? This cat, this image result, and this image, both of them look the same way. Can you tell me what is the difference? If you see this cat, if you see this cat, how much is the shape? Look at this, height and width. Check this out, all of you. Can you see the pixels? Number of pixels roughly around 3700, 5000 odd something. If you see the shape here, that's what I'm saying. Pooling is applied as a default. You also may have to apply pooling, which is very important when you want to keep the size of the data at a lower value. Pooling is not going to give you any trouble later on. Okay, that is known as the pooling layer. After pooling, we may not see big difference in the final image. What we see is the size will be reduced. Nearly it is said to have halved.